Alrighty, this is going on page 64 when we're done. So earlier this week, you had this that you did with Miss Bruce, right? It had all these rules on it, yes? Which looks so overwhelming until you realize you already know these, right? And then you just, yes, you do. And then you just, okay, these right here, what am I looking for? These right here, maybe not. The cosecant, cotangent ones, but that's okay because they don't come up that much anyway, and we'll talk about them if we need to, but they really haven't even come up. But this looks way overwhelming. Besides what you already know, these are the 5 that you have to know cold, all right? Which, let's think about it. Do you know how to take, what's the derivative of sine? Cosine. What's the derivative of cosine? Negative sine. Okay, so you really do know this first one. We'll talk about it a little bit more in a minute. That means you also know the second one. What's the derivative of e to the x? E to the x, so you know number 3. What's the derivative of the natural log? 1 over u, the absolute value of x or whatever, right? And so that's basically the backwards of that. And then this is just doing the backwards of the derivative that you know. So you do know these, all right? But let's talk trig, sine, cosine here just a little bit, because I don't know if she talked to you about these things or not. But also, the lesson that you did with Miss Bruce was called antiderivatives. This one, we're talking about integrating. Did she talk to you about the difference between the two? Okay, so they're really kind of used interchangeably. An antiderivative and an integral, you can use the words interchangeably. But the difference is, if I want to take the integral on a graph from like 2 to 3, and I'm finding the area under the curve, that's an integral. And an antiderivative is literally undoing the derivative. So basically, they're the same. You just can't say I'm going to take the antiderivative from 2 to 3. That doesn't make any sense. But other than that, they're really the same. So you'll hear them used interchangeably. But here's what, you know how pst helps you and some of those other things? When we're talking about the antiderivatives here, let's talk about sine, cosine, negative cosine. I think I've shown you this once before to go and take derivatives, right? So if I'm taking derivatives, it works like this, right? The derivative of sine is cosine. The derivative of cosine is negative sine. The derivative of negative sine would be negative cosine. Derivative of negative cosine would be sine, right? So if you can line that up and understand that for derivatives, you're just going backwards for the antiderivative or the integral. So if you're going to integrate cosine, you're going to get sine. If you're going to integrate negative cosine, you're going to get negative sine. Does that make sense? So you're just going the other way. So you just write down that list, and are you going down or are you going up? And there you go, you got those taken care of. Okay, we okay with all that? All right. So, it says, you'll notice in the table above and the larger table of all the integrals you should know, which, again, you really do know them. Each of the integrals is being integrated in terms of u du instead of x dx. Okay? On the AP exam, it is rare to find questions that involve x by itself. Instead, we find functions that include expressions involving x. So not just x, but it involves x. So let's look at this. Oops. So we know, you'll see, the derivative, so if I integrate cosine, I get sine, right? We know that from up there, the little thing that we did there. But if I integrate cosine of 2x, it does not equal sine of 2x. But also remember that we don't have, there's not really a chain rule, not a product rule, a quotient rule. Those things that we had for derivatives doesn't work the same for integrals. So in order to integrate the second equation, we must use a method called u-Substitution. Hence all the u's that are in everything. Here are the strategies. Okay, so we'll do this. I'm not going to read those to you, but if you forget, you can come back and do this. This is what we're about to do here. Okay, so flip it over. And I'm going to start by, because this will only take halfway, I'm going to kind of give you the, oops, did I not bring my papers up here? Oh, don't do that. Okay, I'm going to show you what your integral can look like. Now, we've integrated things from 1 to 2 or 2 to 3, but one of the things you should have looked at with those antiderivatives, that it's just as a whole, we're not doing it for specific numbers. So we're going to integrate, what do I have down there? G of x. Okay. F of g of x times g prime of x dx. Okay. All right, so we don't have, that looks like we use the product rule to take the derivative. Would you agree with that? Okay, but we don't have a product rule to take the antiderivative or the integral. So what we do instead is look for a function inside of a function. Just like you would in order to do the product rule, we're looking for a function inside of a function. I see this one right here. Would you agree with that? So I'm going to replace that with u. And I'm going to say u is equal to g of x. Everybody okay with that? Maybe something similar. Yeah, we did do something similar to this for a little brief period of time. I don't know if I called it u-Substitution, but sometimes you have to do things like this, yes. Okay, so then I'm going to take the derivative of both sides with respect to x. Okay, we good with that? So that means on this side over here, I'm going to have, oh, well, I just tried to change colors and that didn't work. Du dx is equal to g prime of x. Everybody okay with that? All right. Now, I don't want du over dx. I just want du. So these really we can split because that is like division. So I can multiply both sides and get du equals g prime of x dx. See that so far? We good? All right, now let's look at how we are going to substitute in here. I'm going to take the integral, and I'm going to have f of, what did I say g of x was equal to? U. Okay, so I changed that g of x to the u, right? Just substitution. You with me on that? All right, and then I'm going to take this du is equal to g prime of x dx. Well, here's g prime of x dx. So then that's going to be du right there. Okay. Then I can integrate that function, whatever it happens to be, and then go back and substitute stuff back in. Okay. Yay, I know. But here's one step we're going to skip in this. We're going to skip this step. Instead of doing this and multiplying both sides by dx every time, we'll just have, if I'm going to take the derivative of this, it's just going to be du equals g prime of x dx, or whatever it is. Okay, we have a dx over there. You'll see what I mean in just a minute. But basically, like I said, we're going to skip this step. I just wanted to make sure you knew kind of where it was coming from. Right, so that's just kind of a generic. We didn't even take the full integral, but let's see what's happening over here. And it is possible that sometimes you choose a u that you think sounds really great, and then things don't work out very well for you. That's okay. Maybe we chose the wrong thing. Because when I look over here, when I'm looking for a function, I mean, I do have this 2x, but it's not really inside of anything, so I don't think I want to choose that. But this is a function inside of a function. Would you agree with that? So I'm going to say that my u is going to equal x squared plus 1. Everybody with me? Then I'm going to take the derivative. So that means I'm going to get du equals what? 2x dx, right? Don't forget your dx there. All right, now, some of them work out pretty nicely where this right here matches this. Okay, you got to make sure that you're going to be able to account for everything. This is going to be my u, right? And then this is going to be my du. And is that a 5? Because mine's a blur. Yes? Okay. So that means when I integrate it, instead of x squared plus 1 to the 5th, it's going to be u to the 5th. And instead of 2x dx, it's going to be du. Everybody with me so far? Just substitution. Ask me a question if I've lost you somewhere. Okay. Now, can we integrate this? What is our rule? Okay, it's the opposite of taking the derivative, right? This is just going to be your exponent rule, your power rule. So if I was going to take the derivative, which I'm not, I'd multiply by 5 and subtract 1 from the exponent, right? So when I integrate, I add 1 to the exponent, right? So this is going to be u to the 6th. And then I divide by my new exponent, like this. Or you can put a 1/6 out front, like whatever works for you. I think it's probably best most of the time just to add 1 to the exponent, divide by 6. Now then you can always ask yourself, if I took the derivative of this, would I get this? If I multiply by 6, the 6's cancel out, and then I subtract 1, I would get that, right? So it's just literally opposite. Add 1 to the exponent, divide by your new exponent. Then what do I have to make sure I put? Plus C. You got it? Okay. So now, we're not 100% done, right? So now we just substitute again, and my u is still x squared plus 1. So I can leave this as x squared plus 1 to the 6th power. I can put it over 6 and do plus c, or I could have put a 1/6 out in front, but you don't have to get fancy, and you don't have to simplify it. So hopefully if you got that and it was multiple choice and there was an option that said 1/6 in front of that, you could figure out that it's the same. It'll be good. Okay. What questions you got? We good? What is the plus c? Okay, so if I took, because there's some constant. If you take the derivative of a constant, what do you get? 0, okay? So if I took the derivative, when I take the derivative of this, I need to be able to get this back. There's some constant that I took the derivative of and got 0, but I don't know what it is. So without knowing something else, without them giving me a point, like eventually we're going to figure out what the c's are once we have more information, but I don't have the information yet. Okay, does that make sense? We good? Okay. Alrighty. And it's possible that the constant was 0, depending on what it is. We don't know, so you have to account for it. And it absorbs a lot of things. There are times, and every time it happens to me, I have to check with either Mr. Ackerman or Miss Bruce because I always feel like I'm wrong. But, bless you. When you integrate things and you and your neighbor, and it won't happen a lot, so I don't want to freak you out, but you might integrate it, and if you do something a little bit different, like if maybe one of you factored something out and the other one didn't, you can get different answers in the end. But it's okay because of this plus C, it absorbs so much stuff. Both of the answers are technically right. So I always have to have somebody reassure me of that because sometimes it makes sense and sometimes it doesn't. But like I said, it's not something that should freak you out. Just throwing that out there. Okay, so let me give you a couple of pointers here that we're going to write over here because we don't need all this room. Let's see what I want to say. Here's what we want to make sure we do. We want to make sure that we eliminate all x's from question. Okay, meaning that when I substituted in and things became orange over there, if I still had an x there somehow, that's a bad thing. Okay, so I got to eliminate all the x's. And number 2, use one of the 9 antiderivatives we know. I think there's only 5 on the front here, but you know more of them. So I'm not sure why I have 9 written down because it's fine. Okay, one of the, it doesn't even matter how many. Use one of the ones we know. You have those 9 that you have to know cold. I'm not sure on the front there is, yeah, like secant squared's not on there, but that's something that you'd be able to handle. Things that you're familiar with, okay? Stop doing that to me. Okay. All right, so let's look at this next example. What do you think we should try for u? Okay, here's the other thing. I don't want to just use the x squared. That wouldn't help me any, right? I need like the whole thing that's inside of something. So let's use that. So we're going to have u equals x squared plus 3. All right? So when I take the derivative, I'm going to get du equals 2x dx. You agree with that? Okay, so when I look over here, this, I know my square root is going to have the u inside of it. I have an x dx, but I don't have a 2x dx. As long as it's a number, like a constant, and not a variable, we can totally take care of that. Because if I need to multiply by 2, that's fine as long as on the outside of the integral, I have a 1/2. That makes sense? It's kind of like adding something to both sides. Because you can because I can factor that 2 out in front of it, right? And so if I factor that 2 out in front of it, it just becomes 1 again, because I need this to be inside of here, and that's where all of this comes from. See the 2x dx there? Do we need to rewrite it? I'm going to rewrite it. So I'm going to rewrite what we had. I'm going to leave some space here. So let me do it this way. I'm going to integral. I'm going to leave a little bit of space. X is the square root of x squared plus 3 dx. That's what we have, right? I need to put du in here, but I have to, in order for me to put du in there, I have to replace this. And I have the x dx, I don't have the 2. You with me on that? So in order for me to just put 2 in here, I can't just change the value of it. So I basically need to divide it back out on the outside so that it has a value of 1. All right? So would you agree that 1/2 times 2 is 1? So would you agree I have not changed the value of this derivative, of this integral? Yes. And I did that because, again, I have to make this match. And I have this 2x dx right here because I can multiply in any order. There's what my du is going to be coming from. Yes? So when I do my integral, I still have this 1/2 out here times the integral of, well, I'm going to take this first. And that'll now be the square root of u. And then that's multiplied by all of this, which is actually du. Okay? Everybody okay with that? Okay, it'll get better with some practice. It's kind of like you being able to multiply both sides by 2, but there's not a it's both sides of the integral symbol. It's not really the both sides of an equation. All right, so I would suggest we rewrite this as 1/2 times the integral of u to the 1/2 power du. Right? It's better to look at it as an exponent. Okay, so I'm going to get 1/2 times, all right, so I need to add 1 to the exponent. What's 1/2 plus 1? 3/2, okay? 3, so u to the 3/2 power. And then I have to divide by my new exponent. Now you can put that over 3/2 if you want, but I think we would all agree that it's probably better if we just multiply by the reciprocal. Would you agree with that? It's the same thing. So I'm going to multiply by 2/3. And then I have my plus c. Okay? Everybody okay with that? So if we want to clean this up a little bit, 1/2 times 2/3, what happens to those 2's? They cancel out. Yeah, so these are going to cancel out. So that's going to leave me with 1/3 times u to the 3/2 power plus c. Do you know what u is? Yes. So that is equal to 1/3 times x squared plus 3 to the 3/2 power plus c. Okay. What questions you got? Nothing. Okay. Let's try another one where we're going to have to do something a little bit different like that. Any questions at all? Okay. Here we go. All right. What do you think we want to use for u? Good. I would say u equals 3x squared plus 4. Okay. So let's take du. Du would equal what? 6x dx. Very good. Okay. So my u will take care of the square root in the denominator, right? I need 6x dx. Do I have 6x dx in there? No. So in order for me to put this 6 in here, which is multiplication, what do I have to do outside the integral? Multiply by 1/6. You okay with that? All right. So now I'm going to have 1/6 times the integral, and instead of 6x dx, that's where... Okay, well, I don't know where I stopped or how I did it. I must have hit it with my finger. Thank you. you for telling me. Yeah, I would have been mad if I got to the end and realized that. All right, so 1/6 times the integral of, now we said that is going to be u to the what? Negative 1/2 power times du, right? Now, when you know that you're going to have a fractional exponent, you can leave yourself a little bit of room when you write so you don't have to put it afterwards like this. Okay, so let's do that. Because we have a fractional exponent, I'm going to have to divide or multiply by a fraction, right? I have this 1/6. I'm going to leave myself a little bit of room. When I add 1 to the exponent, what do I get? I get 1/2. Negative 1/2 plus 1 is 1/2. Y'all agree with that? Negative 1/2 plus 1 is 1/2. Yes, I know. The hardest question ever. It's 1/2. And so then I have to divide by my exponent, which means I'm multiplying by 2 over 1. And then I'm adding c, yeah, which is just 2. So that means that 1/6 times 2 is going to be 1/3. And then this 1/2, I can leave it as that, or I can put it back as a square root. And that is the square root of 3x squared plus 4 plus c. How are we doing? You've been better? Yeah. Questions? Okay. Well, it's not really about getting rid of the fraction. It's about making this into an exponent so I can use the exponent. Does that make sense? So yes, sometimes, and in most of the time, we are going to try to get stuff out of the denominator, but there still may be a time where there's a fraction. But yeah, then it was more about making this into something usable than trying to, yes. Because just like if I was going to take the derivative of that, I would want to write it as u to the negative 1/2 to be able to do my power rule, right? So it's the same concept there. Okay, good question. Anything else? All right. So let's look at this one. What do you think we want to use for u? 3x. Okay. So u is equal to 3x. So du is equal to what? 3 dx. Well, I got a dx. This 3 doesn't count for me, right? So I'm going to have to multiply by 3, which means what do I do on the outside? 1/3. Good. So I'm going to rewrite this as 1/3 times the integral of the cosine of u, and then this right here is what is my du. When I integrate cosine, what do I get? When I integrate cosine, I get sine, right? That's why writing those little things down can be very helpful. So it's just plain old sine. So I'm going to get 1/3 times the sine of u plus c. So then that gives me 1/3 times the sine of 3x plus c. Now, if I was going to take, if you need to check yourself, if you were going to take the derivative of this, right? You take the derivative of sine, we know that is cosine, so it'd be cosine of 3x. Okay, there's that 1/3 out there. And then you do the chain rule, then you multiply by 3, and then those cancel out, right? And this is what you have right there. You can always take the derivative and check yourself and make sure you get it back. Okay? And the derivative of c is just 0 because it's a constant, right? Okay. We good? So if you get something weird, you're like, I don't know, you can check yourself. As long as you do the right rules when you check yourself. We good? Alrighty. So what do you think about this one? What are we going to use? X to the third? Yeah, I think I'm going to use what's inside of here. So I'm going to say u is equal to x cubed. So du is equal to 3x squared dx. Now, there's a lot of these problems where we're having to do the multiply and divide thing, but they're not every single one of them is going to be like that. I wish there had been a couple more that weren't before we got started, but it's all fine. So I'm looking for this because I know that this will be taken care of with u, but then this right here, I have an x squared and a dx, so what do I need to multiply by inside? 3. So multiply by 3 on the outside, that's a 1/3. And then I double check that all of this stuff, I mean, you can rewrite it in order if you want to, but that's a lot of rewriting, and I know you're not going to do it. But I can multiply those in, and it's not necessary. You can multiply those in any order. That's where your du is coming from. And then we have this. Now, remember we were taking derivatives, and we had like secant squared or cosine squared, and we needed to, instead of writing like secant squared of x, we wrote secant of x in quantity squared. Sometimes we want to leave it like that. Sometimes we want to put it like this. So if I'm going to integrate secant squared, what is secant squared related to when we take the derivative? Tangent, right? So I don't think I need to rewrite it any differently than what I have. I can just leave it as 1/3 times the integral of secant squared of u du. And so your pst still works, right? If the derivative of tangent is secant squared, then the integral of secant squared is tangent, right? This goes the other way. So I get 1/3 of the tangent of u plus c. We good? And then I just put in the u, and I get 1/3 times the tangent x cubed plus c. It's not. It's not bad. Just got some drama queens in here. Funny how you just assume I'm talking about you. All right. I'm going to give you a minute. I want y'all to try this one on your own. Huh? Just get it started. What? Oh, you don't have the other piece of paper? Never mind. Yeah, flip it over again. And flip it over again. There you go. Now you have it. Yeah, see if you can figure out what you would use for u. See where you go. See where you can get. Not that far. What are we trying to use for u? 5x? Okay. That's what I just wanted you to at least get that far on this. Okay. Okay. I'm just going to rewrite it. Oh, that's not this. Do you agree with what I've done so far? Yeah? Okay. Do you feel like we can go any farther? We really can't because there's not a product rule, right? The u-substitution we've been doing to get rid of something that was like for the product rule, right? Now that doesn't mean we can't integrate this question. That just means we didn't pick the correct U, which is going to happen sometimes, and that is okay, right? You have to learn when you get down that road. If you can't force it, I can't go any farther. So we're kind of stuck here. So let's look at this differently. And instead, let's rewrite what we had. We had the integral, and like I said, instead of sine cubed of 5x, can't I write that as the sine of 5x cubed? Doesn't that mean the exact same thing? Just the other way is just how the notation works. And then we're going to have the cosine of 5x dx. So now, can you look at it a little differently and pick a different u? What else is inside that we could use? The sine, right? So I can pick this part right here and say that u is equal to the sine of 5x. Yes? Okay. And I don't think most of us would recognize that if it was still written like this. So with the secant squared, we knew that secant squared was related to tangent, so we didn't need to. These don't relate that way. So rewriting it kind of helps you see what you really need to do here. So now then du is equal to, what's the derivative of sine? Cosine. And so cosine of 5x times what? 5, because it's a chain rule. So this is really 5 cosine of x dx. Everybody okay with that? So now we know that u is going to be taken care of with this. Oh, cosine of 5x dx. I'm so sorry. Dang it. None of y'all stop me. 5x dx, sorry. I was so worried about the chain rule, I didn't leave the inside the same. So it's the derivative of sine at 5x is the cosine of 5x times the derivative of the inside, which is 5. I just left off the 5x. All right, and so then I need du. I have this part, but I need to multiply by 5 out here. So out here I need to multiply by 1/5. We good now? So now I'm going to have 1/5 times the integral. So this u goes right here. It's going to be u cubed. And then my du, all of this goes together right here, du. Everybody with me so far? Those are the moments I'm waiting for. I can wait for a second. Make sure, does everybody understand where everything came from? If you do not, please ask me. You may not be the only one. Or even if you are, I don't care. That's fine. I can re-explain it to you. Are we all good? I don't believe you, but okay. So then when we integrate, we have this 1/5. I know I'm going to have to divide by my exponent, so I'm going to leave room for another fraction here. 1/5 times, so I add 1 to the exponent, that's u to the 4th. Then I divide by 4, so that's like 1/4 there. And then plus c. So then I have to substitute my u back in. So 1/5 times 1/4 is 1/20. And then this is going to be sine to the 4th of 5x plus c. That's your answer. Okay. What questions we got? All right, so now I want you to try the next one for real on your own. Do you think maybe you want to rewrite the original? Yeah, I'd say if it's not a secant squared, that's probably a good bet there. So. I didn't have to rewrite this. I just did because I like it better that way. Did anybody choose a different U to begin with? No? Okay, then tell me why you're confused right now. Well, you said, huh? And what? And gave my board a dirty look. It's got to mean something. Well, but does that mean you're confused? I want to help you. You got it? Okay. Why I did this? You got it? Okay. Everybody else good so far? Okay. So then I need Oh, I didn't do it right though. See, that's why you were looking at me. That's not right. Is that why you were giving me dirty looks? That should be 2x, right? Yes. See? Okay, so chain rule. I messed up on the chain rule, which I keep telling y'all not to mess up on the chain rule. When I take the derivative, I know it's negative sign of whatever's in there, and then I have to take the derivative of that. The derivative of that is 2x. It is not 2, which is what I had originally. So I just rewrote it like this because I like it better that way. Okay? But it doesn't matter either way. When I come back over here, for my du, I have sine of x squared dx right here, but I don't have the negative 2, and here's the x. So I got to multiply by a negative 2 inside of here, so this has to be a negative 1/2 out here. Then when I put this in, I'm going to have the integral. All right, so this stuff is all taken care of by the du. This is where my u goes, and I have a negative 1/2 out here, u to the 4th, and then again, all of this is my du. Can you finish it? Might be better off than me helping you because apparently I don't even know how to take a derivative. Ask me a question. You got it? There we go. Good. Where'd I lose you, Jen? Oh, that's... Uh-huh. Oh, that's totally fine. Same thing. Totally fine. Totally fine. No. Yeah, no. We'll be able to manipulate them like we did here. There's a couple of little like side notes of little tricks you can do, but then there definitely are questions where that happens, but that's more BC integration. So we won't get crazy more complicated than this. Yeah. Like, how's it going to work every time? It actually doesn't work every single time. It'll work on the questions we have. Okay, that's a good question. All right. Yeah, hang on to that. We will do a few more examples tomorrow, and you will have time to practice.